All right, welcome to part 2 of 11.3. So, I'm going to let you guys kind of try to tackle this question first, and then I'll go over it as we've done before. But the coordinates of the vertices of quadrilateral HIJK are H14, I32, J -1, -4, and K -3, -2. If quadrilateral HIJK is rotated 270 degrees about the origin, that means we're going to go counterclockwise, what are the vertices of the resulting image? Quadrilateral H prime, I prime, J prime, and K prime. Okay. If you didn't write down this table before, okay, make sure you do that now. And this table is going to be very helpful for you to figure out what the prime rotation is going to be, okay, what the prime image is. So go ahead and take a moment on your own to see if you can figure out what the vertices of the image is going to be. Okay, guys, so for this one, without having your coordinate plane, you really want to use the rules that are here. So for H, okay, our x-coordinate was 1 and our y-coordinate was 4. So since we're rotating 270 degrees counterclockwise about the origin, our original x and y is going to help us make our prime. So the x-coordinate is going to be the original y. So our x-coordinate is 4 in H prime, and our y-coordinate is the opposite of x. Well, x was 1. So the opposite of 1 is -1. So H prime is 4, -1. Let's take a look at I. Well, to go from I to I prime, same thing. We have xy, and we're going to write it. Our x is going to become y. So our y was 2. Our I prime is going to be 2. And our y coordinate is the opposite of x. The opposite of x be -3. What was 3? Now it's -3. Let's look at J. J, we're going to get a little tricky here. Okay, so J to J prime, if we have xy, because 270, we're going to go y -x. The y was 4. We're going to write 4. Now the x here was -1, and we want the opposite of x. Well, x is -1. The opposite of -1 is 1. So J prime is actually 4, 1. Yeah, hope you remember that this was meant opposite, not just we're going to write a negative here. All right, now let's look at the last one. So we have -3, -2 for K. K prime, we're going to use the y for our x coordinate. So we're going to put -2 as our x coordinate. And then our y coordinate, -x, or sorry, the opposite of x. I just tricked myself there. The opposite of x, so we have -3. The opposite of -3 is 3. So K prime is -2, 3. Once again, if you haven't written this table down, make sure that you do. Now keep in mind, as I said, this is for counterclockwise. Sorry about that. Okay. If we want to do just clockwise, okay, it would actually be these, but in reverse order. Okay, so if we were going clockwise, this would be 90. This is still 180. 180 pretty much stays the same. Okay, and this would be 270. So if you were going clockwise, which, like I said, it's not very common, but if you were, then it would actually just go the opposite way there. Okay, so if you want to make a little note, this is counterclockwise. Regular clockwise would be just the opposite way. Okay. Now let's describe a rotation. So we've done where I've told you what the rotation was, and I want you to figure out what the vertices were. Now I want you guys to try and describe the rotation that's happening here. Okay. So we have quadrilateral, and this looks like it would be pretty close to a rhombus. I'm going to call it parallelogram. No, they call it parallelogram. So A, B, C, D, and parallelogram A prime, B prime, C prime, and D prime. And we want to figure out what its rotation is. To do this, just like we did with the other ones, we want to draw rays from the origin to a point from the figure, and it's a point from the image that would be its prime point. So in this case, they choose A and A prime. I always recommend to choose the one that's closest to the origin. That way you don't get it all confused with the other lines. So they draw a ray to A and a ray to A prime. Now, since we're rotating counterclockwise about the origin, which is this way, we would need to figure out what this angle is. Now, some of you might right away, and it's perfectly fine if you do, might try to identify this angle. Once again, perfectly fine. I understand that. Just know, since we are going counterclockwise, we're focusing on this angle. Okay, if you do figure this one out, then you would be able to figure out the other, because in the coordinate plane, going all the way around one time is a 360-degree angle or a circle. Okay? So we would then need to figure out what this angle is going to be. Without your protractor, you can figure this out. Okay? When we went from here to here, that was just going to be 90. If you actually extended out these rays, you could see that. So from here to here was 90. From here to here was 180. So from here all the way around 3/4 of the way must mean that it's going to be 270. And we would need another 90 to get to the 360. So when you do that, it's going to look similar to this. So this whole angle is a 270-degree angle, and that's what we rotated it about the origin to get our new figure. I want you guys to think about an answer, or just try to come up and describe what's another way that we could identify this rotation. Okay, so we say this is a rotation of 270 degrees. Is there any other way that you could identify this rotation? Go ahead and take a moment with that. Okay, guys. So another way that you could describe this is actually that this is a negative 90-degree angle. So it's the opposite. You're going the opposite way. So a negative 90-degree rotation, or you could call it a 90-degree clockwise rotation. Okay? As I mentioned before, it's not common, but you can actually go clockwise. So you could describe this as a 90-degree clockwise, or just negative 90. Okay? How do you know it's 90? Because this was 270. It would take another 90 degrees to get to the full 360 to completely rotate it back to its original position. Okay? I want you guys on your own, see if you can figure out and describe what the rotation is here that maps triangle FGH to triangle F prime, G prime, H prime. Take a moment and do that now. Okay, guys, so for this one, once again, since we're going around the origin, I recommend picking and drawing your rays closest to the origin. So I'm just going to pick H and H prime. You could pick G and G prime, or F and F prime. I'm going to pick H and H prime. So I'm going to draw a ray, not bad, from the origin to H, and do the same thing from the origin to H prime. Now, as I mentioned before, we're going counterclockwise for all of our rotations. It's easy, okay, it's easy to get caught up and go clockwise, okay, but we are going to go counterclockwise here. Okay, so what is this angle rotation that would move H to H prime? Well, if you notice, our rays here, okay, actually form a straight line, and any straight line angle is always going to be 180 degrees. So this would be a 180-degree rotation. Now you can get more specific. I'm not going to write it all out because it would take a while, but you could get more specific and say 180-degree rotation, or 180-degree counterclockwise rotation about the origin. Okay, so that way you're naming your rotation, You're naming the direction that it's going, and you're naming your center of rotation, which is the origin. All right. I have a couple more examples that I want you guys to try now, and then I'll go over those answers. So I want you to identify what are the coordinates of the image of trapezoid A, B, C, D after a 270-degree rotation about the origin. Use graph paper, use that rule chart that I gave you. If you didn't write it down yet, again, you can rewind the video and go back and make sure you write it down because it's going to be super helpful for you. I want you to figure out what all the vertices are for what the image is going to be. So A prime, B prime, C prime, and D prime. Go ahead and do that now, guys. So for this, we're going to go 270 degrees around. So here's D and D prime. So you can mark your rays out and measure out 270 degrees. It might actually be easier in this case to just measure the negative 90 degree or the 90 degree clockwise rotation. It's 270 degree on the protractor. It's not going to be possible there. So, so when you do that, you can use your chart, and we have A is 1, 3, your rule chart. A prime, you're going to take the Y, and that's going to become our X. So we have 3, and then we're going to take the opposite of X, and that's our Y coordinate, so 3, negative 1. B, which was 3, 3, the B prime is 3, negative 3. Okay. So I can write the rule up here. So then for C, we have 5, 1. And then we're going to take Y, write it for the X coordinate, and the Y coordinate's the opposite of X, so we get negative 5. And then D, and D prime, D was 1, 1. D prime is going to be 1, negative 1. You take your Y, it becomes your X coordinate, and your X coordinate becomes the opposite. Your Y coordinate becomes the opposite of whatever the X was. Okay. Couple more. All right, I want you to take that same original image that you had before, and now I want you to rotate the trapezoid 180 degrees about the origin. Give that one a try now, guys. All right, for this one, once again, you need to break out your rule chart. For this one, your rule is pretty simple. You take the opposite of X, and you take the opposite of Y. So A, once again, to draw it out, you would start from the origin, draw your ray through the closest point to the origin, and then you would draw a straight line ray going the other way since 180 degrees. You're going to rotate it counterclockwise to that point. Okay. And as I said before, you're taking the opposite of X and the opposite of Y. So A was 1, 3. A prime is going to be negative 1, negative 3. B was 3, 3. B prime is negative 3, negative 3. C was 5, 1. C prime is negative 5, negative 1. And D was 1, 1. So D prime is negative 1, negative 1. All right, last one for you guys. I want you to describe 2 rotations here that map triangle NOP or NOP, so NOP, to triangle N prime, O prime, P prime, and give an explanation with that. Go ahead and do that now. So 2 rotations that could be described here. The first one that you guys should pick out is a 90-degree counterclockwise rotation about the origin. Okay. Also, if you go clockwise, you would get a 270-degree rotation as well, or a negative 270-degree rotation if you're still dealing counterclockwise. Okay. So those are the 2 measurements that you get there, and this just gives a little more explanation. If the rotation of the pre-image is counterclockwise, the measure is 90 degrees. If its rotation is clockwise, you could say it's 270 or negative 270. Okay. All right, guys, that's all I've got for today. Remember, for your homework, use graph paper on Envision 7.3. So 11.3. Use graph paper. Make sure you write down the vertices, the one of the original and the image, the prime one, and then you have that rule written down because that'll help you with the rotations without having to draw it out with the protractor. Okay, have a wonderful day, and I'll see you guys next time.